Welcome to this lecture on the confidence interval. Hopefully some of the other videos will be a little bit more fancy and give you some better visuals, but I'm going to kind of explain in a nutshell what's going on and hopefully answer some common questions that we have from the homework 3. So let's go ahead and get started. The first thing I want to address is what is a confidence interval. So basically, when you're taking a confidence interval around a mean, you're using the theory of the central limit theory that says that when you take a bunch of different sample sizes, right? When you take a bunch of different samples, here's a sample and I calculate that sample mean. And here's another sample and I calculate that sample mean. And here's another different random sample and I calculate that one. And another one and I calculate that one. Now, it turns out that when you do this, the true mean, which does not change, is right here in the center of this normally distributed distribution of sample means. So like here's one sample and then a bunch of samples here that all get this number and so on. And so all the different possible samples are listed. And this is the very rare sample where you happen to pick all of the smallest numbers in the set or all the largest numbers in the set. And this is the very rare sample where you happen to pick all of the smallest numbers in the set. And as you build this sample, these sample means, you end up with a normal distribution that looks like this. And then you say, well, what happens if I take a sample and I build a confidence interval around that. So let's say I took this sample right here. I got this sample and I got a mean that was right here on my number line. This is my number line. Zeros here and whatever numbers, our max numbers up here, whatever, however that works, whatever our borders are. And I got a sample who had a sample mean right here. And then I say, well, what would happen if I thought of this sample mean as the true mean? It's not the true mean, it's the sample mean. But I built a normal distribution around this sample mean. And I went 2 standard deviations away. And you see that I actually capture that true mean in this new range, in this 95% range. 2 standard deviations away is 95%, which we know from the empirical rule, and we know from calculating the z-score for the number 2. For a standard z-score, we would get 95%. So I go that far away, and I get this. I would capture the true mean 95% of the time that I did this. The only times that I wouldn't capture that true mean would be the times where my sample mean was up here, right? I'd go 2 and I would not capture that. And those only happen in these corners 5% of the time. So basically, when I say I'm 95% confident, I'm saying that if I did this process 100 times, 95 of those times, I would likely capture the true mean. I have a 95% chance of capturing the true mean. The true mean doesn't move. What I am doing is I am taking a sample and hoping that I got a sample close enough to the true mean that I can capture it most of the time. So how do we build these confidence intervals? Regardless of what statistic I'm using, we always use a point estimate. That's, in this case, a point estimate is one point that describes the statistic that we are trying to communicate. So for us, for this chapter, it is either the sample mean or the sample proportion. And then we plus or minus a margin of error, how likely this is based on how correct we want to be. So if someone said, hey, Carol, can you hit that target? And I'd be like, how accurate do you want me to be? I'm 100% confident that I could shoot and hit the side of a barn, hit something, right? So the more confident I am, the larger my target has to be, the larger my range has to be. The less confident, the smaller. So if you put a normal target up there, then I'm not very confident because it's a smaller range. So when you say 99%, you would expect your range to be larger because you're more confident. If you say 60%, you're going for a smaller range, so you are much less confident. You have a tighter range. There are pros and cons to, obviously, if you say I could say I'm 95% confident you're going to get between 0 and 100% on the final. That's not super helpful. But if I said I'm 74% confident you're going to get between an 80 and a 93 on the final, that's much more helpful. That's a more helpful range. So there's this balance between it being helpful and a usable size and also being accurate. So anyway, we plus or minus the margin of error. For a z-score, it's going to be, for a z-interval, where the population standard deviation, then it's going to be the sample mean plus or minus your z-critical value. And this is the number that you get from your confidence interval, times your population standard deviation divided by your square root of your sample size. This right here is called your margin of error. This right here is called your standard estimate of the error. Standard error. And this is your z-critical value, which you pull from a standard normal curve. Right. And I'll write out the proportion one in just a minute. We'll talk about this for just a few minutes. If I have a standard normal curve and say someone asked me for the 74th percentile, or a 74th critical value, I would go here and here so that I had 74% of the area in the middle, which means I have 26% of the area out here in these two regions, which means I have 13% here and 13% here. Now, because I've asked you to have TI 84s or 83s, I will walk through real quick how you find that critical value for a number like that. So I would turn my TI 84 on, looking for the 74th percentile number. So for critical value, I would hit distributions, which is second, vars. So you hit the second key, and then the vars, and above vars you see it says distribution. And then I would hit inverse normal. So inverse normal, which is number 3. So I select that, and it asks me, do I want left, center, or right? Not all the calculators have this. Most, if you were doing this Excel, they would only give you the left. I'll use the left option. So the area on a left, in the left tail, given 74% in the middle, we just said was 13%. So I'm going to put left, I'm going to put 0.13 for where it says area. My mean is 0 and my standard deviation is 1 because this is a standard normal curve. And then I hit paste and I get negative 1.126. So this absolute value of this number right here, my Z critical value, is 1.126. Now the calculator gives you the negative because this is on the left tail, zero's right here, so you would expect this to be a negative number. If I were looking to try to find, if I used the center button, I hit second vars, go back to number 3, choose center instead, change my area to 0.74, and then hit enter twice for the paste. It will give me both the negative and the positive version of this. And you'll notice that it gives me lots of decimal precision, which is really nice, which is going to make my numbers more accurate. So that is how we do the confidence interval for finding those critical values, right? Now, one of the nice things about the TI-84 is it does have an immediate confidence interval. Like it will calculate the confidence interval for you directly. Let's say I took a sample and it had a sample size of 82. And the standard deviation for the population, I happen to know from previous studies, is 10. And my number of my sample size I took was 26. And I am looking for the 98th percent confidence interval. All right, so I would go to stat, go over to tests. So I hit the stat button. I go over to tests, and then I choose number 7, which is a Z interval. And I have summarized statistics, not data. If I had a list of data, I could enter that list into L1 and then choose data, but I have statistics, so I'm going to choose stats. It asks me for sigma. I'm going to put 10. It asks me for my sample mean. I'm going to put 82. It's going to ask me for my sample size. I'm going to put 26. And then it'll ask me for my C level, my confidence level. I'm going to put 0.98. I hit calculate, and it will give me, so now it will give me my confidence interval, which is going to be 77.4382. And then that's my lower limit, and my upper limit is going to be, and it just spits this right out for you, 86.562. Now, that is saying that my true mean is somewhere between this and this. 98% of the time, this will be an accurate assessment of where that true mean lies, if I do this process over and over again. However, question number 2 doesn't ask for it in this form. It asks for a confidence interval again, but this time it wants the mean, which is 82, plus or minus the margin of error. Your calculator doesn't spit out the margin of error without you doing some extra work. So it doesn't just say margin of error. At least the 84 doesn't. The 89 will, but the 84 does not. So what we're going to do is we are going to recognize that this confidence interval is plus or minus a margin of error. So the mean is smack in the middle here, 82. So if I take that 77, 0.438, and I add it to my 86.562 and hit enter, I get 164. And I divide that by 2 and I get 82. So you'll see, again, the mean is smack in the middle of your confidence interval. Right? These are not one-sided confidence intervals. They should be level. Right? So now I'm looking for this margin of error, And it's going to be the difference between my upper limit and this limit. So there's two ways I can calculate that. I can just take this 86 point that and subtract my 82 away from it, and my margin of error is 0.456234. Or I could do the same thing and subtract 82, take 82 minus the 77.438, and also get the same number. So I can subtract the endpoints. Or I could actually calculate the margin of error. So I know that if I have a normal curve with 98% of the area in the middle, that means there's 1% down here and 1% over here. And if I go to my distribution like I did in the last slide and go inverse normal, and I put, I can just put 0.98 in the middle if I want, choose center and paste, that my critical value is going to be plus or minus 2.32634,347. So it gives me all that decimal precision. If I take that number, times it by my standard deviation, divide it by the square root of my sample size, I get 4.56234, blah, 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 blah. Like, so on. So you'll see that this is the margin of error. I can calculate it using the actual equation for the margin of error, or I can use the shortcut for the confidence interval on my calculator, and then the confidence interval on my calculator, and then subtract the mean from there. Anyway, hopefully that is helpful. Watch the other videos. Let me know if you have questions. I look forward to chatting with you all. Thanks. And we will be live on Wednesday night. Thank you.